sort of weird subject is that at PyCon US, I was asked to do a tutorial. So I prepared this tutorial about 3D graphics with PyScript. So like with Python, WebGL is like, how you actually make 3D things appear on a canvas on HTML5. That ran for like 3.5 hours. 35-ish people showed up. Usually when I create a thing to do public speaking with, it takes more or less 10 times the time that it gives to give it later. So if it's like a 30-minute talk, 300 minutes. So 3.5 hours, that took forever to prepare. And then 35 people showed up and they're like, yeah, it was cool. So I felt like, you know what, like, wouldn't it be nice to be able to like show it in more places, but we don't have 3.5 hours. So instead of like making this a full tutorial where you have assignments and you're trying to like debug stuff, I'm just going to show you through this entire program of it. I'm going to show you through the code. I don't expect you to like understand every line at the moment. I'm just showing you what the breadth of it is. All of the code is on GitHub. All of this code is on PyScript.com. You can check it out. You can poke at it. We're just going to know like all the building blocks after this like more or less hour of my talking today. But before we begin, hi, I'm Lukasz. I come from the internet. Like you can find me on GitHub. You can find me on Mastodon and Blue Sky. Used to be also like Twitter, but since that's an ex-social network right now, the account is still there. I don't post there anymore. But yeah, like when I had a real job at some large corporation and whatnot, Python was almost like a hobby to me that I tried to like shoehorn into the job, but it was a hobby. So I went to conferences and I gave talks about like Python, look, features like decorators, typing, whatever. And now that it is actually my core job, somehow it just feels boring to me to just talk to you about my job. You know what I mean? So like I have other hobbies, kind of I have some artistic pretenses, like, produce some music to like shoot some photographs, which like Scotland is like super photogenic. So like I'm in heaven here. And also do some visualizations for the music I do, because if you post something on YouTube and it's just an image, it gets less, interest than when stuff gets moving. So stuff can be moving, like when you're doing some 3D visualizations or something like for the sound that you're making. So like an example of this might be something like that. Where am I? I'm now on. This draws random paths for them or every now and again. That's actually really like we're drawing it. Looking at it, listening to the music, more interesting than just listening to whatever. But it is synchronized. So sound, which what? Yes, but examples I don't claim any ownership to this. Like everything that we're gonna be talking about is like essentially CC0. Just copy it. Like you can use it like at Sky or like in your job. I don't care. But the thing about this thing is that like the browser is essentially the dream come true for Python. Like as far as I can tell, because you don't need to know pip install. You don't need to like explain to people that, oh, this is how you install this on Windows. You have to have a virtual env. No, don't have a virtual env. Use UV instead. Like, do this thing. Use conda. No. You just point somebody at a URL and then stuff just works, which is amazing. And not just a web page, not just some code that you have on your front end, but you can really interact with hardware. And like, for example, you can have like a controller, which is actual hardware connected to your computer, and the browser through APIs in Chrome can actually interact with things you have. And like there's support in the browser to do like Xbox controllers, like keyboards, mouses, and mice. But this particular controller is very custom. All of this actually now like creating most of the traction. But it's still in this life. Big games, right? So there's this competition called APUG. It is like every 6 months, but in September you cannot see anything. It's really red on red. I'm sorry. This is like this tunnel racer that I made in a few days. So in a week you're supposed to make like a game that people can play. That was September 2023. Like there was a game. Didn't win the competition, but I made it like in a few days, and people could play it. They didn't have to like again, do any Windows or Mac OS installation, like fiddle with stuff. Like they could just like check out the URL and play it. So for last September in 2024, I did like this rhythm game. You just press space, and if you don't do it right, like the screen gets progressively red, and then you lose. Like it actually does lose at some point here. But the thing is, you can do like all sorts of interactions, like interactive modes with the technology I'm going to show you, and I find it extremely inspiring that this is something that like regular Python programmers can now do. And it doesn't really require like much in terms of like, I don't know, background. I didn't have much background in graphics before I dove into this. Yeah, you lost. Look, there's a terminal, and this is actually, foreshadowing. Yeah, in any case, you can do stuff that like almost achieves 120 FPS, and it wasn't 120 because I was recording the screen, but like, and the performance of it is surprisingly good as well. So this is what we're going to be doing today. Like, I just wanted to show you a bunch of examples so you're like, okay, like when we're going to be starting, it doesn't look impressive at all. So, you have to have like at least some view on like, it's going to get a little better over the course of the hour. So again, we are working with WebGL, which does not know anything about 3 dimensions. What WebGL is, it's a rasterization engine that can draw triangles. And everything else that you want to do with it, you need to program yourself, which we won't be doing, but that's how WebGL works. It is based actually on the embedded version of OpenGL, and we're not going to be talking about something that's even more low level that is called WebGPU, and it's the sort of newest way to interact with a GPU in the browser. WebGPU allows you to also do general purpose computation on a GPU. So in the age of AI, that is like, of a lot of interest in, users of computers, because now you can move some of the computation that a model would do to the client. It might happen on somebody's phone or something. We're not going to be talking about this. We're talking about the middle one, WebGL, a pretty old technology by now. The spec is like 10 years old, but only in the past 3 years, we actually got like all the browsers on all of the devices, including like iPhones and stuff, like actually support this. So now you can point any phone at the right. So 3JS is a library that actually does the 3D on top of the rasterization engine that is WebGL. I am in love with this library. It is a wonderful library. It is extremely what it's doing. It does its job extremely well, which is doubly impressive in JavaScript that is famously bad at numbers. But somehow it does work very well. But obviously you're like, dude, this is a Python meetup. We should talk about Rust. Now, we're going to be talking about Python, but in fact, PyScript, which is a way to have Python in the browser. Not like Django with Fast API where you're hitting a server. This is actually running on the front end. So or in your browser, it might actually run without internet connectivity, which to an extent we're going to be using today. Like I am connected to Wi-Fi because there's the Zoom call that like I'm in, but like otherwise everything is bundled. So I was prepared to be essentially Wi-Fi independent for today. So what is PyScript? It does allow you to have an interpreter in the browser. Like this particular example that is showing here, like on PyScript.net, like is MicroPython. So this is already like showing you, oh, MicroPython, that is a little strange. Well, there's two kinds of Python that this supports. Like the first one is a bunch of scientific libraries made to work on the browser. Its upside is that it is the Python that you know, and you can use like pandas, numpy, scipy, and a bunch of other stuff with it. There's like a micro pip that you can just add dependencies and it's magically working. But the client, so your customers, people who actually go to your webpage, need to always download all that you're using, like every time. So, you know, the startup time for that might be somewhat excessive if you're overly generous with your dependencies. Language called MicroPython. You know, like if you squint, it's Python, but if you look very closely and you start using it, like there's some rough edges. Like it is not really something that was first designed to work in a browser. It was designed to work on 64 kilobytes of a microcontroller, and that shows the algorithms that it chooses for its implementation of dictionaries and stuff like are a little dumb, like for a big computer like language, programming language, but are super smart if you only have 64 kilobytes of RAM, because they're very memory conservative. That actually causes like the WebAssembly port to love it. Like, so if your code is small and doesn't do too much computation, MicroPython tends to be actually faster than Pyodide. But if you actually bring more data to it, like the roles sort of flip. Plus, MicroPython is missing a ton of like things that you might be expecting to have like in Python, like data classes or even stuff like datetime.now. It's just not there because most microcontrollers don't have a real-time clock. So I usually start coding with MicroPython with PyScript because it starts instantly. It is like it allows us to be more interactive and so on. But as soon as actually, you know, some big boy needs, you know, appear, like then I'm like, okay, switching to Pyodide, which is why there's gonna be some boilerplate in our code so that we are MicroPython or Pyodide and switch between them seamlessly. So PyScript is also PyScript.com, which is different from PyScript.net. PyScript.net is the technology. PyScript.com is something that Anaconda will probably sell in the future. So far, they're giving it away, which is this platform where you can code in PyScript in the browser. So you don't have to like install anything. You don't have to like configure your editor or whatnot. You just go there and you start your projects. I have a few projects already created on PyScript.com. I really like it. In particular, the tutorial that I was giving and the thing that we're going to be playing with is in a collection that is called PyCon US 2025. So if you want to actually play with it in the browser, you can just go there and click through the projects. And if you click through them, one of them might look something like this. So you're going to have an editor on the left, and on the right, you already see like what the output looks like. So you can make changes and click run again and see it. It's like a nice and productive environment put on GitHub that forgoes PyScript.com. Since on the tutorial, people are like, but what if I don't want to have any dependency on a subscription-based thing? This is not subscription-based yet, but I imagine that they're not going to be giving it away forever. So yeah, fair point. So now like I'm going to be coding in VS Code and just using a local HTTP server to just like, show you around, sort of tied to this sort of platform. But it is very easy to use it to just bootstrap your kind of project or idea, or just try it out with whether PyScript is interesting for you at all. So again, you don't have to follow every line. You have to understand every little concept, because you can just go on my GitHub and just clone this repository, or on PyScript.com you can do about it. There's plenty of things like the DOM and the document object, the window object, and so on. Those interact with you through JavaScript. So to talk from Python to JavaScript, what you're doing is you are using a foreign function interface. You are calling functions that look like Python functions, but actually Pyodite or MicroPython behind your back is converting this to calls to JavaScript. The languages look similar enough that you might wish for there to be a perfect layer of translation between their languages, but alas, it's not perfect. There are some things that will clearly show you that you are interacting with a different language. If you do have this mindset that that the reason why it looks weird is because I'm talking to a different language. If I talk to Rust or I talk to Swift or I talk to C++ right now, I would expect there to be some level of weirdness. There is a level of weirdness with the JavaScript stuff too, but that doesn't mean that you cannot read the JavaScript documentation when you are trying to learn 3JS. 3JS is a wonderful library about 3D in the browser. It implements a lot of things correctly. It has plenty of examples that you can almost copy and paste to PyScript as well. You just need to change a bunch of little details. You can leave semicolons in essentially, in fact, if you do it a lot, which I did, you'd start putting semicolons in your Python code then as well. A little embarrassing is what happens. There is no new keyword in Python. So there's a bunch of little differences that you need to have bear in mind. But other than that, the code is very self-explanatory and you can follow the official documentation, which also is to say you should be following this documentation of PyScript as well that explains in great detail how this foreign function interface functions in both Pyodite and MicroPython, what the differences are, and so on and so on. So since we're not going to be going through all of that today, I highly recommend you not to do the same mistake I did and to assume that they don't have anything interesting to say and just poking at it until I got frustrated, because there are answers here that would save me some frustration if I wasn't so stubborn. So I recommend you do the same. So now let's look at some code. I have this other desktop here with some code already open. That is the repository that I told you about on GitHub. And there's 9 consecutive exercises that we can go to through. First of all, already has the index.html file open. And if we open it in a browser, that's the tutorial one here. Okay, let me exit. Okay, now I can see actually what I wanted to click. It looks something like this. There's going to be a grid of spheres. They change colors, and you can interact with it. I'm dragging stuff right now, or I can use the mouse wheel to just zoom in and zoom out. There's a terminal here as well, which is just Python, so I can raise exceptions and maybe do something useful as well. And as you can see, we are actually at 120 FPS, which is amazing because that means that this monitor does 120 hertz. The browser is a magical engine to run your applications. So if that monitor was 60 hertz, which is usually the case, the FPS that you could get in your application online would be essentially sealed, you have a ceiling of 60 FPS because 60 hertz is what the display does. The browser tries to be energy efficient. That's what it's doing. So that's the example. How does it work? So first of all, to actually do any Python in the browser, what does it mean? Well, it is part of a web page, like this index.html. And to actually have anything appear, you first need to link CSS and a JavaScript file from the core PyScript. So here I'm bundling it, but normally you would probably either use a served version from PyScript's website or some JavaScript build system if you already use React or something large. It will be much easier for you to add another NPM dependency. So there's a CSS file, and then there's also a JS file, which is what is actually setting up the web page such that you can then create script tags that have a type of either Py or MPy. MPy, MicroPython, Py, Pyodite, the big boy. When you have a MPy or Py type script, what you do is you point it at a source. So that's our main.py file, and at a configuration file for PyScript. In our case, the configuration file contains just a few things that we will need. For example, it says that the interpreter we're using is just MicroPython from my offline bundle and not from online. Otherwise, it would try to download it, so it wouldn't work on the airplane, or if Wi-Fi didn't work here. You can also specify other files that you will want to import, which I do here because it would be a security hole to just allow importing of any possible file that might appear on a server in the same directory, because you don't know what you're going to be running. So you have to declare all files. And then JavaScript modules. So if JavaScript depends on other JavaScript, you need to declare that here. And you can also import that from Python as well. We're going to look at this next. So this main.py file is not really super long yet. In the first example, it's like what, 87 lines, but it's a bit of a lie because here it imports lib3 on the top, which abstracts away some things that we're going to be looking at next. But before we do, let's get two things out of the way. So first of all, as you can see, I do a bunch of stuff that sort of abstracts away whether we are on MicroPython or not. This is because I want to be able to switch between MicroPython and Pyodide at will, which, for example, means that I have this sort of like new function that I'm using. So when you're creating a new JavaScript object, I am using this built-in, I guess, this function to do this. If I need to pass arguments to this JavaScript objects while creating it, I just pass it as other arguments here. The reason why I need a silly function here and I cannot just use the regular thing that the FFI of my MicroPython or Pyodide provide is that both Python versions here disagree on how to deal with keyword arguments. So I just made this silly new function just so that I don't have to rename all the keyword arguments when I switch from one version to another. And I recommend you do the same, but you do you. And the second thing to get out of the way is, how do you even set up a 3D application? What are the main building blocks and what does Three.js expect us to do? So first of all, you need to create a scene or more. Your application can have more than one. It's like a micro world where you put 3D objects in it. And then to actually put it on screen on a canvas object, you need to have a renderer. It will render something onto a canvas element on your web page. The camera is what actually is going to be rendered. It's how you view the world. And there's two kinds. There's three kinds really. The first one is the perspective camera. So that means if you have parallel lines, they will meet at a horizon, right? So that's how we look at the world. So it looks natural. But there's also another one that is pretty useful, which is the orthographic camera, which is like, people call it isometric. Not entirely correct, but it's like if you ever played SimCity or any other RTS games, this sort of thing, like isometric. You look at it maybe kind of a little slanted from the top. It has very many uses. Parallel lines will never meet, right? That's how that works, even if like they go into the distance. The third kind of camera, we're not going to be touching it today, is a VR camera. So you can have a stereographic camera so that it produces two images, so you can use a VR headset with a browser today, which to me is incredible. Three.js is a great library. We're going to focus on the two basic cameras, which is the perspective one and the orthographic one. So the camera says, what does the user see? And that is going to be rendered by the renderer. And to have any sort of interaction, you can either implement it yourself from scratch, or you can use some controls that Three.js already provides. It turns out that the math to actually do any sensible controls with a 3D application is frustratingly hard to get right, such that controls feel natural. So when you're dragging something, when you're, using a controller, it sort of appears that like it's doing the right thing. So when you're walking around with cursors, it just doesn't feel like you're jumping too far, So all of this is already implemented by Three.js, so you can just reuse the controls that you already have instead of inventing your own. But as I showed you with the example with the weird controller, hardware controller, you can do it if you want to. So we have a scene, we have a renderer that like looks into a thing, but what will it render? It will render objects that are lit. So they reflect light in some weird way. So you need to put some light. Ambient light here is the simplest one that we can have. Like essentially it means there's illumination is the same, you know, in the entire scene. So that's the simplest thing. You add those things to the scene. So then we have this for loop inside a for loop where we add more things to the scene, just spheres. And what are 3D objects in Three.js? They are meshes that are combining two things, a geometry and a material. The geometry just essentially says, what are the triangles? How are they combined? Because everything is triangles. You saw spheres here, but they're not. Like if you zoom close enough, you will notice that like there are walls here. Like they're not spherical like perfectly, but zoomed out enough, not really distinguishable from a sphere. So it's triangles all the way down. So that's the geometry. And material essentially says, how is the light reflected? It can be very simple, like it is right now, but it can also be extremely complex later on. That is essentially what makes 3D graphics sort of look realistic to us. So yeah, we add this bunch of things to the scene. This is like a silly function that if I did resize my browser window, what I'm actually doing is quite possibly not only changing the size of the thing that we're looking into, but also the aspect ratio. So we need to inform the cameras like, hey, the new dimensions are different now. So that's like some boilerplate code, doesn't really mean much. But here we get to the fact that I can touch the things and drag them and it sort of reacts to what I'm doing. It doesn't look like an animation, but it is, because it is essentially like refreshing at some number of frames per second. And every frame is drawn by our animate function that is already called by the browser. We're not calling it in a silly loop. What we're saying is the browser, when you're done with everything that you need to do, you tell me when the next frame is necessary, when it's needed, and call me. So that's how you set it, like in the set animation loop on line 84. This function does have this weird @create proxy decorator over it. That's because we are putting a Python function in the JavaScript world saying you can call this later, but that Python function needs to still exist on the JavaScript side in the future when JavaScript will want to call it. If we just put this as an argument to a JavaScript function, it would create the proxy and then delete it right away, which would be very sad. Like you would just get like a very cryptic exception for that. So it's one of those places where like the FFI bleeds through. It's not entirely magically transparent to us, but it does work. The last line here that does something is this code interact that allows us to actually do things to the program while it is running. So for example, we already have this list of spheres here, which is a bunch of JS proxies. That's not super helpful, but that's how MicroPython actually like shows you that those are JavaScript objects. So the first one of them is one of those spheres here. As far as I can tell, like it's going to be the one on the bottom right. So what you can do is it, for example, has a position. It's another proxy, obviously, but like it's like X, Y, and Z. So we can change this X to be like, I don't know, 10. And now you can see this change position. This is actually super useful because you can kind of interact with the scene that you're building interactively. Interactively. In any case, like it is very useful to have the terminal here and be able to just fiddle with it instead of restarting the application all the time just because like you don't like the color quite much. It does have a scale. We can actually set the scale to like change the object to look like way different, right? Like it still doesn't quite look right. Actually, see, it's a disk right now, but we can make it like a large sphere right now. So as you can see, like this is the interaction that like we're doing with actually JavaScript objects, which I find incredible. This is a Python repo. So yeah, so that was exercise 1. And since I'm already like talking for close to 40 minutes, we need to speed up a little bit. But don't worry, like the setup and how all of this is built like takes a little while. Before we move on to tutorial 2 and everything else, let's just peek at the lib 3. You're like, what is this doing? Like this is calling a ton of JavaScript APIs from Three.js. In fact, in JS, there's 3 kinds of ways to import things. So those 3 examples are there for you. So if you ever see like, you know, those 3 kinds in JavaScript documentation, you will know how to actually express this in PyScript. This default thing here like took me ages to figure out. Like I don't know why this is the way it is, but it's how they figured it out. Okay, cool. So I already told you about my silly new function. So see, like we're creating a bunch of Three.js objects here and configure them. I'm not going to be explaining this like, you know, line by line. The split here is essentially just like a framework that allows us to have the terminal here and hide it if we want to hide it. Like, so it's that's why it's here. We have a perspective camera, we have an ortho camera, we have some controls, which are orbit controls. So it allows us to orbit around a center point, essentially, with dragging, like, you know, mouse, with the mouse. And then StatsGL, which is this wonderful library that shows us that we are performant, because performance. Great. Actually, this is cool because sometimes you do something silly and Python is what is slowing down the scene. So you'll see that CPU is what like goes up. But if you're doing something where you created hundreds of thousands of objects and now like your GPU is actually not that happy about stuff, like you're gonna see that the GPU, the yellow thing, is going to like blow up. So you can actually judge where your slowdown comes from, which is really cool. I like this particular library a lot. So moving on, tutorial 2, let's just display this in the browser. That's Chrome. I don't usually use Chrome, but I use it for WebGL presentations because it is guaranteed to do everything exactly right. So I can just focus on content and like not that Safari did not implement a tiny bit of WebGL properly or something. So normally, like you can depend on different browsers, whether it's on a phone or on a desktop to work like exactly the same. But there can be edge cases, like where like, you know, different browsers behave in different ways. So tutorial 2 is the same essentially as the first one, with the like one of the things that I told people to do is like, hey, at least make the, you know, size of the spheres change, like, you know, on the grid, so we can change how they're different. And this is like a good opportunity for us to actually look at the cameras. As I told you, like the perspective camera is such that you can see how, like, you know, kind of the distance makes this scene kind of actually be different depending on the coordinates. This middle thing right here, like almost looks, if you align it right, like as if it was like a single sphere, but the others clearly show that there's some perspective going on. What is fun here is that if you change the camera, which I can show you how to do here, from perspective camera to the orthographic camera, boom, and we just restart the thing, you can see that now actually everything is aligned perfectly, right? So that's the orthographic isometric camera. And it has a lot of uses. For example, if you're going to be doing data visualization, probably you're not going to want the perspective camera. It looks cool to have bar graphs that go into the horizon, but it's not really that useful. Like it's sort of overdoing on the artistic side and under delivering on the, you know, being able to compare sizes side. So orthographic camera, great for many use cases. I use it a lot as well because it allows us to, like, you know, kind of play with the sort of RTS style visualization of stuff. Right, so that's one of the things, but boom, I press space and there's another scene, because that's another thing I wanted to show you in this particular example, that you can make more than one scene and change between them interactively, which is pretty cool. This particular scene is what we saw before. It has a grid, it has some light, it has still the spheres with the for loop and a for loop that create the grid. The size is now changed, so like we actually are using the like, you know, the thing like to set up the size for the geometry. So grid size X, so it becomes larger as we go, right? But there's also this not. Again, 3JS, great library, so it already provides you with many geometries. So like you don't have to create like all of the primitives and connect the triangles yourself. You can use plenty of geometries, just configure them somehow, and just use that here. I used this particular geometry to show you one particular detail, that this is lit from the middle, right? It looks like there's a light inside it that shines on the object from the inside, so that the parts like around it are dark, but the parts inside are bright. And that's what is happening here. You see that there's a point light that is set up like right in the middle of the scene. And that's what actually is like emitting light. And again, because we have a terminal, we can now address this light and play with it. So we have some active scene. That's the scene that we're currently looking at. And it's going to have, that's a scene object. So we can get an object by name. We're calling JavaScript right now. And we have a point light. It is nicely called point light because I named it such here. And with that point light, we can play with stuff like its intensity of the light. Intensity. It's 1 now, but if we just say 0, lights out, like there's nothing. But if you say 10, now it's like super bright, right? And it also can have different colors. So the current color is just some proxy, like it is probably RGB, it's white, but we can change this color to be, say, red, and now it's super red, it's aggressively red. And also change the position of this light, because currently it is in the middle, but if we say position X is 10, we see how now it is changing how this thing is lit, right? Like, so we can play with stuff interactively pretty nicely with 3JS. And that was our active scene before. Now the active scene is something else. Now, if we try to get object by name point light, we're going to get undefined because the scene changed. And now it's an object again, and so on. So how do we do this? You just connect to the browser events, like on key down, and just say, oh, if you're not in the terminal, because actually changing scenes when you're saying space in a terminal would be silly. So if you're not in the terminal, space would just change a global to active scene. Later on, we're going to move on from just functions and globals, because that's not how we factor code. But for now, it's just simpler to just show it like with fewer lines of code that way. Again, we have our window resize, and now we're just animating whatever is the active scene. So we render the active scene. We don't render anything else. We render the active one. So that was tutorial 2. Tutorial 3 right here is, again, is already moving on to some more interesting things. So let's see what that does here. So here, lights changed. We no longer use the silly light that we did in the previous grid, but also I'm showing you that 3JS is a great library. So it is not only delivering on the 3D graphics front, but it also allows you to program with great like ergonomics, which means you have those helpers to plenty of things. And this particular light helper really allows us to see where this particular light is positioned. So changing this is allowing you to see like, oh, why is this entire scene dark? Oh, because the light is somewhere out there and I need it here. So those helpers are just set up like this. For us here, you have this directional light helper, and you just add it to the scene like anything else. You just say that this directional light helper helps with this particular light. It's one thing that I also like discovered like while working with 3JS, make stuff much easier. And on the other scene, we now have 2 lights. We have this sort of light that we had before that lights the scene from the middle, but we also have this sort of cone spotlight that does this like menacing red from the top. But it's not really the top anymore if you do the kind of orbital controls here. So what if I wanted this light to stick to this one place when I drag things around? That is actually a good question, because there's 2 ways to do it. Either when you're interacting with a 3D application, you're going to be looking from the same spot and moving all of the objects around, or you're going to be moving the camera around plus the things that you want to appear as if they are not moving. And everything else, you just don't touch, and they appear as if they move, but you stay in place. So it's like either or will cause math to be easy or hard for the things that you need to do. So if I actually wanted this cone to stay in place, that's what tutorial 4 is doing. And here you see, okay, it actually does stay in place. So I can, when I zoom in, it's no longer lit but by the cone that is now in the back. And if I zoom out, at some point it's no longer lit by this red light because it is like they're no longer aligned. But if they are aligned, that's how that looks like. So how did I do that? Like, was that a lot of math involved? Well, in fact, 3JS is all about already using the relations between objects. So instead of adding things to the scene directly, what you can do is you can add things to other objects. So you can group objects together. There is a magic object called group, so it's not actually showing you anything. But here, what we're doing is we are a little smart and we are adding the spotlight to the camera. So whenever we are moving the camera, the relationship between the spotlight and the camera stays the same, which makes them stay in place. And you don't have to do any calculations of, like maintaining position, which otherwise would be annoying math. So 3JS, pretty cool about that. So I'm a little tired of this knot and so on. So let's move on to Aberdeen. Okay, cool. What's new here? There's more geometries and there's more materials that we're looking at right now. So first of all, like what we're looking at is that sometimes things can be really reflective. Sometimes things can be transparent. Sometimes things are like a little less reflective. And there's different geometries here. So you can have text, you can have planes, boxes, or whatnot. All of this is already defined like by 3JS. You just need to configure the object when you're creating it by just passing arguments as you want. For example, the violet thing on the right is in fact a cone, but it is not looking very coney because we just gave it very few triangles. So it looks like that. But if you increase the number of triangles while creating it, it would look more like an actual cone. What you can actually see here too is something that stumped me a little bit at the start, which is the fact that this thing is three-dimensional. And as you can expect, you can see what's behind it, right? Like, so the actual faces that are blocked by the faces that are closer to us. That is not the default in 3JS. The default in 3JS and many other 3D frameworks is to only draw what's in front of you. If that were the case, so we can actually see this by looking at our box. So we have our app object. I'll talk about the app object in a second. Let me just do the box thing first. So this box has a material, and the material has, what is it? Sides. So the side here is just set to 2, which essentially means 3 double side. But you can actually just say 3 front side. In which case, as you can see, that's the default. The sides on the back are no longer rendered. This is great for efficiency. So that's what the default is. But if you actually want to have things transparent and look realistic, it took me a while to figure out why that looked weird. So yeah, there's no backside here now. But if you do double side, yes, that appears now, right? So there are many details about like 3D graphics just like that, where you discover that like efficiency is the name of the game, and there's plenty of just like, I don't know, lying to the person looking at a picture, like just enough that it like looks realistic or like portrays what you want to portray. But other than that, needs to be as efficient as possible. So where does the app object come from? Well, you don't normally want to just write a bunch of functions and then change globals. That is like evil programming. We moved on from that. So what I like to do is to have like a data class where I add the things I want to have in a scene. and then, just configure it in one place so that I can actually now look at this thing like kind of in a nicer way where, okay, there's still JS proxies, but at least I know what the kind of things that are part of the scene are. And I can switch between the scenes much nicer now because there's just a Python object now that I just replace one scene with another. So data classes is the name of the game. And also the base here already, it provides me with a bunch of things I wanted to have. So the scene object that you always need to create, the renderer, the camera, and so on and so on. All those things are just in the base, and like I can just move on to do more creative things. So in time, you start building something like that, like a base for your, kind of new project, so that you don't have to repeat yourself. So that's all that is here. Yeah, like, so we are no longer doing silly functions. Everything is nicely like attributes on objects and so on and so on. One thing that we also did here is now we have this concept of loaders, so that things that happen like asynchronously to load things that we need. So like, I don't know, assets that we need, like a font to render the Aberdeen with, and so on and so on. There's not really many other things happening here right now. Just the app is started, so it animates, and we're done. Let's talk about, so we talked about geometries. Let's talk about those materials, because we already seen like us playing with double sides. But if we go to tutorial 6, there's going to be things that look a little different. So materials look realistically in 3JS and many other 3D frameworks because they just map things to happen on a face. So every 3D object essentially has a bunch of faces. So those are like planes that look at you like in one direction, and you can map things on them. For example, you can bump map. So you can say that vertices should actually go up or down, even though this is a plane. So the blue thing on the bottom is a flat plane that I created, but then I put a bump map with some noise on it, so that now 3JS is just providing those like bumps and like hills and valleys, so that you can see through those shadows that those are not the same height anymore. We can have an alpha map. So here on the box here, we have transparency that is different pixel by pixel. And we can have like other sorts of maps that deform the actual object, like in the case of this cone that looks more like a cone now. So a thing that we could do, for example, here is change those maps that only interact with height of things or transparency of things to like an actual pixel map. We can tell an object that on this face, just draw those pixels. Everybody knows what it is. Those are textures, right? Like, so you just have some like rasterized image, and you just put it on a face. So to do this here in my example of tutorial 6, I already provided myself with a comment that I can neatly change if I do find the right object. Okay, here. So look, just remove the alpha map, create a map. It's going to look very realistically like a box. Only it's not super realistic because it's a really shiny box, and it's sort of bluish too. What is happening? Well, the rest of the material here says that there should be no roughness. There should be some metalness. It should be a little transparent, plus it has a color. If you remove all those and restart our app, now it looks a little more boxy to me, right? And that's essentially texture application. That's just map on a material. That's how you do those things. Now things become much more interesting, huh? So I'm also bored with this Aberdeen sign now. Let's move on to something else entirely, which is, if there's boxes, there's Minecraft, right? You can create Minecraft. Now, like, actually recreating Minecraft is super hard. Like, it just sounds like, look, the graphics there is so basic. How hard can it be? Like many people thought this. So here in particular, exercise to the reader, there is a fun bug here where it is just some noise, like putting like some heights, so like you have like hills and valleys, and I just applied different colors, different materials, depending on the height. but water shouldn't really do the thing where it's so hilly. It should be flat, right? There's a water level. So exercise to the reader, you can fix that so there's actually a water surface. But this is actually created with Perlin noise. So this is fully algorithmic, and it just recreates the thing. So like every time you're gonna have some different island or so, right? Like, you know, with a different mountain on it or so. So that's pretty cool. And now, as you can see, we're no longer 120 FPS, we're 65 FPS. But we can actually do even worse than this if we didn't do the correct thing, because now I'm doing a thing here where I am reusing materials on very many objects in space. When I'm creating those meshes, I'm reusing materials that I created before, which is what you should be doing. But if you didn't do that and say, we just copied this beach right here, commented this with our super multi-line comments of Python, okay, we can make like a material like this. So we create a material for every object. Every time we are, I don't want this to appear here. It is confusing. Zoom, go away. Hide floating meeting controls. That's what I wanted. Cool. So you have this material here that is created in a loop, in a loop. So there's going to be a shit ton of materials now. What's going to happen to our program right now? First of all, it's going to be only beach. So like it's going to be like all yellow. But now you can see the performance tanked. The reason why it tanked is now like there is very little reuse of the materials. Every box that you have here on this grid is creating its own. That's not what you should be doing in scenes. This is very inefficient. Essentially, like it's even more interesting. Like, okay, like if we only show a bunch of those boxes, performance great, 120. But if you show all of them, oh, not so great anymore, huh? So don't do stuff like that. Don't create materials in a loop. Reuse them as much as possible. That includes reusing the textures and everything else. Graphics cards love it when you reuse stuff. Like when we restart it again, we can see that the performance here is essentially doubled, right? By just reusing the objects here, even though some of those materials are now harder to render because there's some transparency here on the water and stuff. Yeah, so anyway, tiny Minecraft that we've shown. But before I let you all go, since I've been talking for an hour already, let me show you the last two exercises that we did in Pittsburgh this year. So first of all, it wouldn't be a Python tutorial without a Python logo, right? So as cute as it is to create objects from scratch in code, that is a little insane if you actually want to make like a game where there's going to be a dragon or like a jet fighter or, you know, whatever else. Like what you're going to have is artists working in real 3D design programs like Blender or others, creating models. And those models are already going to have their materials and their geometries like designed in professional software that is incredibly more usable than trying to use the terminal here and, you know, like figuring stuff out like that. So this is what I did here too. I just found some public domain Python logo 3D model online and put this on a WebGL application. You can do it because one of the very popular formats for 3D models is GLTF. And that format is what WebGL expects and what 3JS supports. So with that, you can find a lot of assets for whatever you want to have, like people, you know, trees, objects, whatever, like houses. Like that's how you actually get to having interesting graphics in your program when it's not all boxes. So that's one thing. And here, like in particular, we do have a tiny little switch to the big boy Python. We are no longer using MicroPython, we are using Py, so Pyodide, because this GLTF loading and other business needs us to be a little more asynchronous. And one magic thing that you can do in the browser is to say, await on the module level. See here, Pylance is like offended. It's like, what are you doing? Await allowed only within. No, we are in the browser. So the browser comes with an event loop. JavaScript is already an event loop. So you can just say await on the module level. And here we actually wait for all of our assets to load. So as you can see, there is a bunch of things that we're loading here, like so those kind of textures and other stuff. And we only start and show the scene when everything loaded. So that's nice. And to do this, you don't have to like busy wait or do any magical things. Like you just await on the module level for the loaded event to fire. Like I find this incredibly satisfying. That like essentially async.io integrates with JavaScript's asynchronicity very elegantly. I love it. So just to show, like, you know, there's like a bunch of logos here. The Python logo is actually just downloaded by this GLTF loader from those assets directory from the scene GLTF. If we actually go into that directory, you will see that it is actually not a single file. The black logo here is just GLB, but the Python logo is an entire directory because there's two ways to like store GLTF objects, either as directories or like as binary files. I like the directories more because they're more like introspectable. You can see what is going on there. So yeah, that was tutorial 8. And the final thing that I wanted to show you before I let you go is that even if you animate things, there's two kinds of animations in 3D graphics. So first is the one that was changing colors in the grid first, which is this algorithmic, you know, generative thing that we're doing so that we actually move things around in every frame. But it would not be possible for us to like have like a reasonable flamingo flight that way. Like you wouldn't be able to move all the vertices in reasonable ways in code. Artists are doing those animations. They are putting them as part of the GLTF object. They're naming them, and then you can trigger this animation in code. And that's the second kind of animation. You either have the algorithmic ones, you do them for larger scale things, or you have the ones that are embedded in objects, and then you just essentially play them as if it was like a video being played back, like in a loop or not. You know, like you can configure them in very many ways. And one of the last things like people on the tutorial were doing is like make the flamingo fly around the logo. How hard can it be? And it turns out that like to get it work, is actually doing the math yourself surprisingly hard. So the animation here, as I said, like the procedural one is us actually changing things like based on the time of the animation frame. But the flamingo animation is just like update the animation that is already embedded in the GLTF. You don't have to do anything, and it's perfect. But if you actually want to have it, you know, circle around the scene, you need to do a bunch of math. So just, you don't have to understand it, but just look at it, right? There's a bunch of like cosines and sines there, and, you know, like making things not super quick, because otherwise like it will be not really the speed that the human eye expects, and so on and so on. This is a little weird to get there, but in 3 hours, if you fiddle with it enough, you would. So the end result really is the flamingo like kind of flying around and not flying around itself or doing something crazy. Yeah, so that's essentially it. Like that's how I personally use WebGL with Python. I find it extremely satisfying because it's a tangible result. Those projects tend to be small, so you can start them and finish them. It's not a maintenance burden for years to come. I really appreciate that. And it's extremely interactive. One thing that you see we lost here by changing to Pyodide is we no longer have a REPL that we can play with. That's on the current Pyodide, that's a limitation where you could either have a REPL or things happen at the same time. Like you cannot have both. This EuroPython in Prague, I fixed that with Hood, who is the maintainer of Pyodide, such that the next version of Pyodide will have PyREPL with like all the colors that we have right now in like 3.14 and so on and so on. So Big Boy Python will have interactive terminal, which I find much, much easier to work with, you know, instead of reloading the application all the time. I appreciate you spending 70 minutes with me. Thank you. If you have any questions, I'm here all evening.
Thank you. So, any questions just now? And also from home, if anybody watching online.
If no questions,
don't be shy.
No problem. Yeah.
I have a very boring question first.
I like those.
Which is how does MicroPython compare to like bar Python, like the restricted Python used by like PyPy?
Right. So our Python is not Python. It has Python in the name, but it's a little confusing. What our Python is a very small subset of Python that can be inferenced like fully when you're looking at a program. What that means is you need to write programs in ways where there is no dynamicism, such that the compiler of our Python can assign types to each value. So it doesn't only know that it's a list, it knows it's a list of integers, right? Or like it's a tuple of this length with something. And by this, like the PyPy team solved this issue of like, oh, there's no type annotations in Python. There weren't at the time, but we really need to compile this to native code. So they made something that looks like Python if you squint, but it is a subset of it. It doesn't have like objects that have descriptors, and you don't have like imports that can do like magic things, but then you catch except input error and do something else. Like, no, it is entirely static, so that the program is compiled into something efficient. So you could use our Python to emit some WebAssembly and then run programs, but that would no longer be Python. You would not be able to have a terminal with that, because that's now fully, kind of statically compiled. Whereas MicroPython, amazing, in the 64 kilobytes on a microcontroller, does have a repo. You can connect to a serial console and type away, right? So that is still an interpreter where you can dynamically put code on it that wasn't pre-compiled. Right?
One more,
right.
More interesting maybe.
Yeah.
For the example you showed us first, where you had a visualization for music that you were generating. So it was synchronized to the sound in one way, but I was wondering if you, like, to what extent you'd experimented with getting different kinds of visual patterns mimicking different patterns of like what's going on in the music.
Right. Yeah. Good question. So, first of all, I've done like a bunch of those things like over the course of January, because there's a group of people that have like this like generative art month, like called January, GEN, like get it, right? But like it is nice. Like every day they have a different prompt, like black and white only, or use only lines or something, and then you're like, I wish what I can do with that. I wonder what I can do with that. So I was playing with those things, and obviously visualization for audio is like what I wanted this for. So how do you know where you are in audio so that you can actually do like some sort of things with it? And I arrived at like 3 sort of ways to do it. Like the kind of most naive way is like, oh, you press play, so you started, and then you count the milliseconds, and then you translate them to it's this beat. So you just have a dictionary with like on this beat do this thing, on this beat do this thing, and so on and so on. But in the browser, sometimes you say play, and it's going to start playing like a split second later, and it's like gets out of sync, and it's like a little annoying. So you're like, oh, what if I do frequency analysis? So I know like, oh, that's a kick drum. So like, it's going to like be the thing. And it was like, well, first of all, it is possible because the browser as a platform already does frequency analysis for you. So it's just built in. You just like, you want to have a sound analyzer, it's there. Like you just call it and you just get buckets and you can read the numbers from it. So it's great. But it turns out like in actual audio and actual like, music, you cannot really differentiate the kick drum from the sub bass from something else. So it's not 100% effective. So instead what I did was, if you produce the audio, you can use dog frequencies. So like at like 22 kilohertz that nobody can hear, you can just like put like a metronome there. It is a superpower because then you can slow down, then you can speed up, doesn't matter. Like, like this is the sort of thing where like this is like bucket 852. So like your counter is always going to count the beats correctly. It's always going to work regardless of like whether downloading it's like the file like took half a second or something. It's always going to be perfect. And nobody's going to like actually kind of hear the pings. Or maybe your dogs are going to get crazy listening to it, but like other than that, like it's going to be great, right? So that's what I ended up actually doing for everything else, and like this is like 100% effective. I like that like a lot. One detail in it, because like we're answering boring questions, you know, so is that it turns out that all of those like gamers who are saying like 30 FPS, right? Like no, 60 FPS or more, like they're right. And the reason they're right is that if you're doing visualization for stuff that is happening in 30 FPS, it doesn't look convincing. It looks like there's something off. It's not actually on time. At 60 FPS, it already starts looking decent, but at like over 90, you're like, okay, this is in sync. Like this looks good. So actually those guys know what they're doing, because usually, and that's also true in games, you only have one loop for rendering and for interaction. So for us, when you're visualizing, you have one in the same loop. If you wanted to all right. Thanks for having me.
Thank you. So yeah, Lukasz, thank you so much. That was a fantastic talk. And it's always great to see somebody who's really on top of the game and knows exactly the topic, because it shines through. Your expertise was tremendous. And I think that's a question from something that popped up on the screen. Oh, hang on, here it is. Thank you, Lukasz. This tutorial is very inspiring. How many months can a beginner take to be good on these kinds of visualizations? What are the career areas for a beginner to be exposed with this training? So
it took me some spurt of programming with it, but like I'm not doing that full time. So it's mostly like, you know, just something on a weekend, or like in January, I'll just do it after hours just to have something done. But it's like, I don't know, like 2 hours per day, or like I mostly learned a bunch of things during like some spurts of like a weekend or two. All in all combined, I think maybe my experience is like 3 months of work, like, you know, but just having already pre-existing experience with Python, but not having any experience with PyScript before that. So that was essentially pretty new to me. And you don't really need that much like to actually have something appear on screen, which is the magical thing about this particular use case. That's starting from something extremely simple and just adding something more to it and playing with that. That's very iterative. So there is not really like a super like impossible learning curve. It is very linear. Like it is very satisfying in this sense. So I recommend it. It is very fun.
So have you, like, during your experience with libraries, have you ever felt the need to transition to 3JS itself, or did you think Python was a barrier?
Oh, like not really. Like what I actually ended up doing, since I was only showing you like, you know, the kind of the fundamentals of everything, but there is a bunch of very simple things that cause all of this to look like kind of way more magical in sort of way. For example, you can just apply a bloom filter that makes everything like sort of like oversaturated, and like the lights are like super bright, or you can apply a filter that looks like you're using a VHS camera, so like it's like old, or like you can apply a kind of lookup tables like that are known like for like color grading for like videos, right? Like, you know, when you look at like Dune the movie, like everything is just brown, right? Like, or maybe green because they're on Caladan, so like, you know, they just color grade. You can also color grade in 3JS. There's like a post-processing pipeline that is very complex. You can do a lot with that. So during the course of this January, I replaced all the 3JS like post-processing with Python, and just made 3JS think that it's still using its own, but it was using mine. So like, you know, kind of, I was actually using more Python than before. So I just found it, it's faster if you don't have to like create JavaScript objects for every little thing. So at some point, like the performance, kind of is a concern. And then you either actually, yes, like just move to JavaScript, which I wouldn't want to do, or just like put more things in Python. But you can do it pretty iteratively, like, as I did, and like that works pretty well. Yes. Yeah. Like as I said, like I had like silly examples because I had like literally a few days to do this, like with bi-week, like 2 years back and last year. And there's actually one coming up just like in 2 weeks. And so I'm gonna be using PyScript with 3JS again for that to just make another game. We'll see what the theme this year is going to be. Whether people do kind of commercial games with it, I don't know. Probably not. For WebGL, yes, they are. There is a lot of mobile games like for Android that are actually not written in Java. Like they are written like as like a little browser window that does WebGL things, just so that it is better supported on low-end devices. But for PyScript, that is very much a technology that is barely on the right side of usable. So you can use it already, but it's still pretty young. Like the debugging experience is not like awesome, which is why you use like debugging prints, like a debugger that you have in the browser would debug MicroPython, the interpreter, or CPython, the interpreter, would not debug your code, which is useless. We want to debug our high-level code, but there's no debugger support for that, at least not yet. So you just need to use parent debugging in there. So are there commercial games using that technology? I don't think so, but you could. And PyScript also does ship with Pygame support. So if like doing sort of retro games in 2D is sort of more your speed, that is also a possibility on PyScript. So there are commercial games released that are written in Pygame. All right.
Yeah, go for it.
Could I ask more about how you debug 3D graphics? Because it's a bit difficult, isn't it? If you have something that looks wrong, but you can't tell where it says.
Yes, so the helper boxes around things like, kind of for lights, for objects, like are really helpful. Plus a ton of printing that actually prints out coordinates of things. So you can actually look like, oh, this thing doesn't align or not. And having it interactive, so having like the terminal where you can actually input things and just move them around, pausing the animation if you want to, because you can just put something there where it won't be updating anything if you press some magical key, is a possibility. So like my debugging usually like just kind of resolves around like being able to print so I can see what the data is, and being able to change it just a little bit with the helpers that you have on the scene that you normally don't display, but for debugging, you can see like where the lights are putting, where we're at, or to have an entire box around a group of objects. Because as I said, in 3JS, an object can contain another object, can contain another object. And then you're like, okay, what is this group even containing? Like, what is the box around it? So like, there are helpers for that. We can see that's your entire group. Ah, shit, I actually wanted 10 groups, but there's just one. And so 3JS is pretty good at like allowing you those like additional things, since those debugging like things are very hard for you to draw yourself. You need to use what 3JS provides, because one of the hardest things in 3D graphics is drawing lines. Because if you think about it, like lines are like a special case where like if you go into the horizon, you still want them to be exactly the same like width and whatnot. You want them to react to light in a different way than everything else. So 3JS provides those like debugging kind of, I don't know, like primitives, and I use those. They're pretty effective. But you're correct that sometimes if you just use sine instead of a cosine, or like, didn't use the right coordinate, of which I didn't know before, there's not 3, there's 6, right? Because you have X, Y, Z, which is like, this is where it is, but then you need to orient the object in 3D in that position. So there's 6 coordinates. If you just do something wrong, like it'll just look silly and you'll laugh, but actually figuring out like, how do I actually make it, for example, like if a model walks, to actually look like it's walking and not like it's moonwalking, So yeah, like I don't really have like super magic answers, but that's how I do it. A little bit, yeah, but like that's high school math. Like you don't need to really know like, derivatives, whatever, like, but like there's like this geometry is literally what you're doing. So like to an extent, there is some sort of like kind of familiarity with math that is very helpful. Because for example, like I was showing one of the examples where like, oh, if you're like rotating something, like, oh, if you realize that using a cyclic function like sine or cosine is perfect for this because it's going to come back to the same position by itself. You just like add more to it and you're done. Like that's good, right? So like, kind of, I'm not particularly skilled at math. I'm no PhD in mathematics, but like you cannot just always just cheat with the fact that like 3JS does give you a lot of like primitives around like positioning things within other things. Like at some point you're gonna have to count things yourself.
How much of the examples, so like lib3 that you were importing and the other sort of like voxel class and stuff that you were showing us today, how much of that did you have to write yourself during that 3 months to interface with 3JS versus how much of that is like part of an existing library that
I wrote everything that you see like
everything.
on the repo like myself. Like sometimes I do attribute that, for example, like the Perlin implementation is just like I saw like a JavaScript implementation, like okay, I don't know the magic numbers what they do. I just like convert this to Python and it does the same thing. So now I have Perlin in Python. That's amazing. I can do hills and valleys. But yeah, essentially, you would probably end up with a different lib3 if you were writing it. But it's just some helpers where you end up having to have the same thing every time you're starting a new scene. So why not just
No, that's really good to know for perspective for the answer earlier of like, oh, it took 3 months to do all of these things. Like we could stand on the shoulders of yourself, but borrow some of that.
Like yesterday in Edinburgh, like somebody asked me like, hey, like should we have like a 3.py? Like yeah, I guess I wouldn't want to maintain it. Like and 3JS, if you look inside it, like it's huge. Like this is like a large library right now. So the surface of it is just too big to just rewrite. I rewrote the entire post-processing thing. So like if you look at my January projects, like from like PyScript.com, the latest ones, like kind of like closer to like 28th, 29th, like 30th, like they have like this post-processing pipeline that like that's all in Python. So that's like a decent chunk of 3JS, but that's only like the last thing that already like processes the entire output of a renderer before it is put on a canvas. And it's using some like, you can use shaders, you can use algorithms that you write in Python and so on and so on. It's nice. But yeah, like lib3 is not completed or comprehensive in any sense. It's just things that at the time would be nice to like abstract out so I don't have to repeat myself every time. All right, cool.
Yeah, well, thank you. It's great. Just a moment, folks. Stop recording.